Hey, welcome to SnykLIVE. Happy to have you all here. Good morning, good afternoon, good evening, wherever you are in the world joining us. We appreciate you being here. And we have some fun in store for you today because today's live stream is focused on stranger danger, the thing you were taught as a kid, right? Stay away from the strangers. There's lots of danger there. I don't know. Anyway, the focus of this stranger danger is on JavaScript security and how your attack surface just got bigger. And I'm not presenting it today. I'm just your host. Your presenter for today is the amazing and wonderful Sonia Moiset, who's going to be joining us to teach us more about this and give us some fresh ideas on JavaScript security. So without further ado, let's bring Sonia on. Hey there.
Hey, hi everyone. Welcome. Happy Wednesday. Wherever you are in the world, good morning, good afternoon, and good evening. I'm Sonia Moiset. I'm a senior security advocate here at Snyk, and I'm going to be taking you through today's session. Stranger danger, your JavaScript attack surface just got bigger. As we said, it's important. I think you will find it, that you mentioned last time, Brian, useful, insightful, informative, all of these adjectives, just add others. So yeah. Welcome, everyone. Before we start, this is an interactive session, so feel free to drop your questions, send your message in the chat box if you want. Okay, cool. Let's jump to the presentation.
Sounds
so what
good.
are we going to talk about today? So we're going to look at the current state of open source security and what are the hot topics these days. We're going to mention the application security space also. We're going to talk about the iceberg, and you might be like the little emoji thinking, oh, what is the iceberg? But I'll tell you about it. We'll have a live hacking session with the help of Patch, our mascot. We'll also see how to fix those vulnerabilities and what are the learnings from all of them. Cool, so let's start with the current state of open source security. So as we know, organizations of all sizes are heavily reliant on software, and we know that much of that software supply chain consists of a lot of open source components, which brings a lot of cybersecurity implications, because it made like an attractive entry point for the attackers, the malicious actors, because they might be interested in theft and disrupting or exploiting for economic or political reasons. Thus, the attack surface is changing. It's getting bigger, and we've seen that defects in small libraries can cause systemic risks. We've seen it with incidents last year, such as Log4Shell. So why application security is important? We know that vulnerabilities can originate from something as simple as a configuration error or using a software component that contains a known vulnerability, which is why maintaining and improving application security is so important for organizations. One recent study revealed that out of 85,000 applications that were analyzed, 83% contained at least one security flaw. And also 20% of these vulnerabilities were one severe vulnerability. While we know that all of these vulnerabilities necessarily present a major risk, hackers continue to refine their attacks by using ingenious workarounds, and I'll showcase some of these to penetrate software. And we have organizations such as OWASP, which is the Open Web Application Security Project, that tracks those vulnerabilities found and provide a list that developers and security teams can use as a starting point for their AppSec program. The most recent OWASP Top 10 list was released last year and included vulnerabilities around broken access control, injection attacks, security misconfigurations, and other. Cool, so let's have a look at some of the open source software attacks. First one, typo squatting attacks. So usually take place when bad actors push malicious packages to registry with the hope of tricking users into installing them. This is really similar to what we have with website phishing attacks that exploit typos made by individuals who may accidentally type in the wrong address. Here we have an example with the package React with a typo, and in that case, you will not install React, but a malicious package that has a completely different end goal. So we've seen that these types of packages in both the Python ecosystem, the JavaScript ecosystem with PyPy or nodejs registries, with the most noteworthy of them being cross-env. So it took the similar name of that popular package, so cross-env. It was cross-env and had wrapped the same functionality, except it also captured your environment variables and sent them to an attacker controller remote server. It was really bad. Another example is a malicious package, which inject malicious code into a software product in order to compromise your dependent system further down the chain. In this example, we're having a package called Fall Guys, and usually the malicious actor will try to surf on trends. Fall Guys tend to be a famous game during the pandemic, and user might think that downloading this package will give them an advantage in the game. So should it be like cosmetics or changing your skin or your character skins, or if you get more things within the game. So in that case, Fall Guys is a malicious package that contains malicious code that attempts to read your local sensitive files and exfiltrate information through a Discord webhook. It was using the Discord webhook in that specific case. And the code attempted to access specific paths available on Windows systems. So basically it was looking through the local storage level DB to exfiltrate your information. Another example is compromising maintainers, where we have malicious actors that will use social engineering methods to gain access to open source projects. Here we had an instance with the event stream package where the malicious actor did social engineering the maintainer. So usually we have the social engineering methodology elsewhere, not really on the open source. This is something quite concerning. But in that case, what happened, the attacker actually went through all the issues from the repository and was finding if he could actually work on a specific feature. And what he did to build up the trust with the maintainer, he pushed some cosmetic changes. So he pushed some changes on the README file, the CSS files. And once he built the confidence, he got access to more permissions. And then he pushed his malicious payload into the code base. And he was targeting Bitcoin wallets. At that time, it was for a Bitcoin wallet to siphon all the assets from the user. So this was really specific in a sense. But his modus operandi was interesting in some way, because it's going through all the issues, see if it can contribute, be trusted, and then push his code. Cool. So this is known as a supply chain attack, also called third-party attack. It occurs when someone infiltrates your system through an outside partner or provider with access to your systems and data. Bad news, it doesn't affect only JavaScript packages. This is an issue for all ecosystem. We had a recent example with Log4Shell within the Java community with a vulnerability in the open source Apache Log4 login library, where we had one of the Log4 exploits that would allow remote code execution on the servers, running vulnerable applications without requiring authentication. That has earned the vulnerability a severity rating of 10 on the CVSS scale on the common vulnerability scoring system. We know that Log4j is used in many commercial applications, and potentially the organizations who are using this package don't really know if their version was vulnerable or not to that specific vulnerability. So supply chain attacks, as we said, is attractive to hackers, because when commonly used packages are compromised, the attacker could potentially gain access to all the enterprise that use that software. Cool, so let's try to understand how this is possible, and let's say hi to the iceberg. If you're confused by that statement, let me explain it to you. So this is the iceberg. So you probably ask, Sonia, what is going on? So our starting point is our code. This is a proprietary code that a developer might write in an organization. Does it bring security vulnerabilities within our code base? Maybe. In that example, we're having a NoSQL injection where we're not sanitizing the user input. And you might ask why? What is happening? So basically here we have a function signature of an Express application with a function which has a request, a response, and a next callback. It's trying to call the user table or collection, which means that there's probably a database behind the scene. It's also trying to do a login, looking for the username and the password. So what are the vulnerabilities here? What can go wrong? So actually, this is a perfect example of a database injection. And in that case, specifically, it's a NoSQL injection. Application built with the Express package will use body parser to parse the JSON object. And it takes whatever you send to and convert it to as a JavaScript object. If the request has a username and a password, this is going to be part of your JavaScript object. And if we're using MongoDB and add the $sign greater than as a key and an empty string as a value, the JavaScript object will tell MongoDB to do a greater than match to filter all the results. And then, for example, if you type admin with that specific key, you'll perform NoSQL injection and basically log in as the administrator on this application. So this shows the importance of sanitizing inputs and to handle this as soon as possible before it's stored in your database. So we start with our code, where potentially we can have security vulnerabilities. This is a piece of code to import a dependency, in that case marked, which is a nice segue actually to the layer below the application code on the iceberg. So the open source code level. If we think about how many lines we code ourselves versus the number of packages we import to cut down the time we spend coding, it's probably the ratio would be higher in the number of packages that we're using, because we don't want to reinvent the wheel, and this is totally understandable. Why would we waste time actually to write something that we know that probably exists as a package in our ecosystem? That's also why we have here with the mark package, because we didn't want to write a library around using markdown syntax within our code base. But we're now bringing several packages into our code base, increasing the attack surface and introducing new risks. So are we aware of all the packages that we have? Are we aware of all the dependencies and sub-dependencies? Do we have a good understanding of indirect and transitive dependencies? Do you have tools that give you that level of understanding and visibility? And also, what are the risks when you bring a dependency into your code base? I know that's a lot of questions, but let's see some numbers around that. So cybersecurity challenges in open source software. The average number of critical vulnerabilities in an application is around 5, and it ranges between 2.6 and 9.5 based on the programming language. There's an average dependency per project of 80, usually, but that's range also depending on the programming language that you're using. The last one is a little bit concerning. It takes almost 100 days as an average number of days to fix a vulnerability. So enough chatting for now, and let's move on to hack an application and understand more about how dependencies can impact your application and introduce vulnerabilities that you were not aware of. So I'll be using the nodejs GUF for that demonstration. You can find it if you go to GitHub, Snyk-labs, you have it here, nodejs GUF. Cool, and this is what the application looks like. So it's a classic to-do list. Let's see, feed, patch, buy food for, if I can type on it, buy food for a patch. Cool, so yeah, that's a classic to-do list application. Now, if I put my attacker's head, I want to actually tamper with the application. What would be some entry points, potentially? If we look at this application, we could see that potentially the URL could be an entry point. Then we have the input here, the input field, that could be also an entry point. And then also probably this here, where we could import some file. Cool, so today I'm gonna demonstrate the URL and the input. So let's start with the URL. So if we look at the URL and, also this like a full-fledged application where you have a lot of dependencies and a lot of logic on the back end. It's not really like a simple to-do application. You also have a lot of vulnerabilities that you can try on it. Cool. So as I'm wearing the attacker's hat and thinking how I could try to traverse the directory and the folders. Let's see. So if I go up from one directory, okay, doesn't seem to work. Let me try with the public folder, because this is where I should see my assets. Oh, okay, interesting. So there's, can have access to it. Okay, cool. Let me go up to another. Oh, this is not working. Okay, so there's good news. There's some sort of sanitization going on here in the back end, but I'm a smart hacker. So I'm going to try with something else. I'm going to try to encode actually the // so going back to this and then coding. Hey, okay, that's interesting. I'm getting more information on the application now. Okay, let's see. What do we have? Docker compose. Just going to zoom. Interesting. Have environment variables here. Cool. What else? Dockerfile. This is giving me a lot of info on the application. Okay. What if I can actually go out of this folder and try to see what we have on the server?
Wait a minute, Sonia. So all you had to do is just add .. backslashes into the URL.
Yes,
and this app
by
is just
encoding it.
exposing these files to anybody.
Yeah, yeah. Wow. This is a vulnerability. You can traverse the URL doing this.
I did not realize that. Okay.
So I'm trying to go up from another level to see if I can actually go onto the server, which apparently I can do. You can see, yeah, great. Cool. So let's see if I can go up a bit more. Interesting. Okay, I'm completely on the machine now. Don't worry, I'm not going to reveal anything sensitive for that. So, okay, let's see if I can. I'm still like trying to go up the from level, and oh, interesting. I have the etc folder here. I'm not going to click on it because obviously this is going to reveal some sensitive info. But you see where I'm going to. So cool. Okay, so this is vulnerable from a directory traversal vulnerability. So let's see what's happening in the code. So first of all, let's have the help of Patch to help us on this investigation. So if we go on the marketplace, by the way, I'm using a VS Code Studio. So if you go on the marketplace and you type Snyk, you'll have the little Snyk ID integration. You can install it. You have to reload your ID for it to take effect. And then you can click on the little patch icon here. The first time you won't see this, you'll see patch telling you to authenticate. So you need a Snyk account for that. Once you authenticate, then you start having all the good things. Cool. So let's have a look at what we have. So we know that for serving, like in this application specifically, for serving static assets, we're using the st package which is flagged here with 2 vulnerabilities. Okay, let's click on the little yellow light bulb. I'm just going to close this and close this. Cool. So we do have a directory traversal vulnerability here, which is introduced in this specific version of the package, and it's fixed within this version. Cool. So what do we have? The good news is we have a proof of concept, so we can read through what's happening. So the versions before 0.2.5 didn't properly prevent the path traversal. Yeah, we've seen that. I got access to the etc password. Oh, it's actually here. Okay, that's a request like this, the one that I prefer, would leak sensitive files and data from the server. Okay, so this is using the // attack for that. Cool. And if you want to learn a little bit more about what is a directory traversal attack, this is like a small description of what's going on. So basically, it aims to access files and directories that are stored outside the intended folder using the // sequence and its variations. And in that case, we actually encoded. That's how we could bypass desanitization. And it's obviously doing information disclosure. You've seen we could have access to some secrets and credentials and other info on the server side as well. Cool. So let's see how we could fix that. So if I go back, so it's saying 0.2.5. Okay, cool. If I go back to the package.json here, just going to zoom in. Where is the ST package? Here. Okay. Just going to change this value. Okay. I'm going to npm install this. Make sure that I'm going to restart my server. We need an animated patch during the npm install. Oh, it was quite fast. Okay, cool. I'm just going to restart the server for that to take effect. Cool. So what I did is just change the upgrade the version according to the recommendation from patch. Cool. So we've done this. I'm just going to refresh now the page. So if we navigate here now, yeah. This is fixed. I cannot see the etc folder anymore. We're getting an error message. We did fix the vulnerability. Yay. Cool. And just to make sure that we've actually fixed it, let's run the here. Should actually disappear from the list of vulnerabilities for the ST package. So let's see. Let's scroll down to the ST package, and we only have one. We had two, the open redirect and the directory traversal. So this is fixed. Yay. Okay. Let's see the second vulnerability. Oh, that's fine.
I was trying to play some sound effects for you. Here you go. Can you hear it now?
Thank you.
Crowd goes wild.
Cool. That's a big crowd. So I'm going to try and tamper with the inputs. So I've demonstrated this is just to-do list application. So this is doing what you would expect if you enter an input. But let's try with some markdown. So start with this. This should be bold. Cool. Okay. Let's try with a link. Okay. So if I click here, I should be redirected to the website. Yeah, working fine. Okay. Let me put my hacker hat and let me do the classic cursive scripting attempt. Oh, boom, this is not working. Okay. Let me try with something else. I'm trying with the JavaScript colon protocol. Let's see. Oh, okay. So there's some sort of sanitization going on. Let's see on the code, what do we have? So we do have the marked package here, and where are we instantiating it? Cool, here. So okay, yeah, we've done our due diligence. We've actually enabled sanitization. So okay, there's some sort of sanitation going on. Cool, but I'm a smart hacker, so I'm going to try other things. Let me try with this. So basically, I'm encoding the colon and the closing parenthesis. Let's see if this works. Oh, it's gone. Okay. I'm probably getting somewhere. Let me try with something else. Let me try with the this keyword. Ah, okay. Getting somewhere. Patch. Ah, it's working. Okay, here we're using the JavaScript colon. Let me just remove this and put it back. So yeah, we're using the JavaScript colon trying to break out of the logic. In that case, in the backend, that somehow is blocking us from hacking the app, because we've seen the sanitization set to true. Maybe the condition that they were expecting exactly the JavaScript and colon protocol, but in that case, we're encoding the colon and adding the this keyword. By the way, this is a valid keyword in JavaScript. I'm just gonna zoom a little bit more so you can all see. I think if you change it with documents, should do the same. Yeah. Yeah. So you can try different variations with window and documents, which are all valid keywords. But as an attacker, it will give me a valid way to write JavaScript and perform an attack, and try to break out from the logic that has been written in the application to prevent my JavaScript to be executed. So you might say that's great. This is just an alert box. Cool. What's the danger in this? So
That
for
was
an
gonna be my
attacker,
question for you, Sonia. Is it
oh
folks who are
really?
watching, they might be like, oh, well, big deal. You're just popping up an alert box on your own window. What's the big deal?
I mean, that's like, come on, it's quite technical, right?
Yeah. I
No,
mean, it's
well,
fun to see.
yeah. No, jokes aside, for an attacker, that's the first step when testing an application, to see if there's any entry point to craft a better payload. So let's say it's not a to-do list. Let's say, for example, it's a social media application where you have a profile, and visitor could actually click on some links on my profile. And imagine you have something like this, and well, actually, it won't be an alert. It would be something like, let's say, if I change this with, so in this specific application, we don't have cookies, so I cannot demonstrate it. But if you manipulate the link to have something more interesting, this could potentially give you information that you could fetch in your server. So in that case, if your application have cookies or sessions, yeah, the attacker could potentially fetch and exfiltrate all of this information.
Gotcha. Okay. Yeah, that's definitely way scarier than just a simple alert box then, right?
Yeah,
Wow.
yeah, exactly. So let's check the code to understand what is going on. Cool. So we've seen here that there's some sort of sanitization, but it's not enough. So let's see. Going back to the package.json. Cool. Where is marked? Marked is here. Let's see. Click the light bulb. Cool. And we have, just going to close this and this. Cool. Cross-site scripting. Yay. So it's introduced in this version. It's fixed in 3.6. Okay. So there's a little bit of info around the marked package. And this is actually what we've done. This payload that we've used for tampering with the application. We use this keyword, not document, but I've also demonstrated that with document you could do it. Cool. So what is cross-site scripting? So it occurs when the attacker tricks a legitimate web-based application or site to accept a request as originating from a trusted source. Cool. This is done by escaping the context of the web application, and we've seen it with the payload that I've crafted. It was actually stored in the database. If I refresh this, it's still within the application. Actually, it's a stored XSS. Cool. So let's fix this vulnerability, because we don't want to have this on our application, right? So if I go back to the package.json and going to upgrade the version to 3.6, just gonna shut the server and do another npm install. Do another Celadance. Thank you. Yeah, that was fast. Cool. Let me start back the server. Cool. And if I refresh now, ooh, it's gone. It has been sanitized. Cool. Let me just try do the due diligence. This is exactly the same malicious payload. It's not working anymore. We fixed the vulnerability. Just gonna remove all of them to Yes. It's gone. Cool. Thanks, Patch. Let's go back to the presentation. So, if I can find my mouse. Cool. What did we learn with these two examples? So first, what I would recommend before bringing components within your code base is to use a website like Snyk Advisor. That'll give you a better visibility of your package. So let's try with marked here. So I've selected NPM here and marked. Cool. And this is the first one. This is amazing. This is like 100 out of 100 for the health score. Great. Obviously, for the application, we've decided to select vulnerable version. But you can see the latest version, they don't have any security vulnerability. That's amazing. Let's see with the other package that we've fixed, the vulnerability ST. Okay, so the health score is 63. We can see that the polar versions are free from vulnerabilities, but it's giving you other dimension actually to judge your packages. You have the popularity dimension, the maintenance dimension, and the community dimension. So you can see the popularity of the package, if it's maintained, when was the last time we had a release. And what about the community? Who are the contributors and maintainers of this package? So just for you to have a better idea of which package you'll bring within your code base is a good thing to do, is like due diligence for your package. Cool. You can also use, so I've used the IDE in that case, and you've seen how it works within your IDE, but you can also use the Snyk CLI. So let me just go back here, clear this. So if I do Snyk test, this is assuming that I've installed the Snyk CLI, I already have it on my machine. If I do Snyk test, it will come back with all the vulnerabilities that I have in my packages. Cool. I can also, if I can type, do Snyk tests with the severity threshold equals high. This is if I only want the highs and criticals in my application. It'll come back with, yeah, as you can see, all the highs and criticals. So depending on if you prefer to have it on your CLI or on your IDE, just to give you options on where you want to fix those vulnerabilities. You can also have that visibility on the Snyk dashboard if you import your project. So in that case, I've imported the nodejs goof, and you can monitor your project automatically. If there's any new vulnerability which are introduced in your application, you'll be notified. Why do you want to do this? Well, you want to audit your dependencies. You might probably want to create an SBOM, which stands for Software Bill of Materials, which is the full inventory of an application and which help the organization understand what their application relies on and identify vulnerabilities or license risks that may impact them. You might also want just to fix vulnerabilities, you want to monitor vulnerabilities, and you want your application to be continuously scanned. So you'll have the same info that you've seen on your IDE. You'll have the where it was introduced through, which version of the package, how is it fixed, and which specific version. You'll have more details on the vulnerability. Oops, sorry. And you also have a link to the Snyk Learn, but I will come back to that because this is really important. The education piece is really important. But what is most important is to fix this vulnerability. So if you click the this green button, you will have you could actually open the pull request where you can cherry pick which packages you want to fix, and then it will raise an elevated pull requests on GitHub, and it will let you know what has been fixed. Obviously, depending on your CI/CD pipeline, you will need to run some tests, but this is a good way to automate those fixes. And as I mentioned, the education piece is really important. So I would strongly recommend you to have a look at the Snyk Learn. So basically, this is free interactive lessons, and it's depending on your ecosystem, you can actually filter it here. So let's say JavaScript, and we have the directory traversal that I've demoed, and you can see here is just knowing more about the vulnerability. And you can also, which is cool, you can try it on your browser. It's sandboxed, so it's safe. You can have a go with the vulnerability. So really cool. Cool, let's go back to our iceberg. I haven't forgotten about the iceberg. So an application needs to be deployed somewhere. We're using containers and static website to deploy our projects, and we have different ways to do so using Docker, Vercel, Netlify, and the different cloud providers. In that case, if we're using Docker, we're adding a Dockerfile now in the equation, which has metadata about your project. So there's this additional layer with modern application. We're running our application as a Docker image, and this adds to the complexity and the attack surface. So again, on your Snyk dashboard, you can have that visibility for the Docker file that you have within your application. And yeah, let's move on to basic Docker files. Let's see what could go wrong with this, because you might probably ask, yeah, Sonia, that's cool. I'm using Dockerfile, but what can go wrong? Well, actually, a lot of things. Let's see them. Here in that case, we have, so this is, as I said, it's basic Dockerfile. But if we have a look at the run apt-get and install image magic, that specific image have vulnerabilities that we probably don't know about. In that case, that one has XML injection, and it had many vulnerabilities. They actually did a whole website to demonstrate and explain how they've fixed this vulnerability. So that could potentially be a point of attack. Installing dependencies during runtime, which is probably not a good thing. It's bad practice to install dependencies on your container, but this is also potentially an entry point. And what about the runtime vulnerabilities? Are we looking at security releases, in that case, for nodes? Are we doing that due diligence exercise by going to the nodejs website and see the latest security releases? If we're picking a large image, it might have many vulnerable libraries. Cool, so going back to the Snyk dashboard, this is the kind of information that you're getting from your Dockerfile with, you can see this purple box or recommendation for upgrading the base image, which give you some guidance of the base image that you could potentially use to reduce your attack surface. And you can see the current image in that case is using the 10.4.0 with 85 criticals. And if you're using another image, for example, this one, you would have, it's free from vulnerability, actually. It's pretty amazing. Yeah, but also it depends on your application, and might have your CI/CD pipeline with different testing. So you can also do the same with the Snyk Advisor. So if I go back to Snyk Advisor here, I'll just click on the drop down and go to Docker. And if I click Node here, yeah, cool. Yeah, so it's giving you also some sort of information around the Docker images. That's insane, almost 4 billion downloads. Wow. And if you look for tags here, let's say node 14, and you want to actually compare with the version that you have in the other version that has less vulnerabilities, you can compare here and see which one you would like to implement. Cool. We do have a cheat sheet for that will cover the Docker image security best practices. But basically, what we've seen is to prefer minimal based images and also use multi-stage builds for that. So basically, during your development cycle, you could use larger images where you have the full-fledged, like all the features. That when you move to production, have a smaller, more secure image for your production build. Cool. You might be asking, if you've been following the iceberg analogy, what's the last layer? So if we go back to where we were, so at first we have the application codes. Okay, this is our proprietary code that we have. Then we're adding packages. This is the open source code level. Then we're Dockerizing our application with containers. So what would be the last layer? Any ideas? Brian, do you have any idea of what could be the last layer?
The last layer. Would that be the icing on the cake?
Oh, that's a good one. Well, no, not really.
No.
No, it's actually infrastructure as code, which is an approach to manage your servers, storage, and networking infrastructure. It's meant to simplify large-scale configuration and management. And this is where, when you provision your resources, you're using code instead of manual processes, and just to make sure that your application processes are scalable and available. So the good thing is you can make your code as your single source of truth where you specify explicitly through code all the infrastructure specification in your config file. You have version control on all of your config files, and also you can test and monitor your configuration, which is cool. But the number one vulnerability on ISE is cloud misconfiguration. And this refers to any glitches, gaps, or error that could expose your environment. And there's a few examples here. So we had the PlayStation Network accounts, there's 77 million accounts hacked. There's also an instance with Uber with 57 million account breach. What happened in that case is their repo went from private to public, and their AWS credits were publicly available. Yeah. And the last one is FedEx breach with 190K scan docs that were publicly available. So yeah, cloud misconfiguration, that's a big one. This is an example with Kubernetes. Here we are explicitly stating in our configuration file to not run as root with the security context rule, and the flag is enabled to true for run as non-root. So having this kind of rules will make guardrails within your configuration files. Cool. So just like to recap on the iceberg, we've revealed the whole iceberg. Now we have a better understanding of what a modern application looks like, and it actually brings a new risk profile. So we've seen that at the top of the iceberg we have our code base, which is only 10 to 20%, but below that level we are bringing a lot of unknown vulnerabilities that are both by the open source libraries with containers and with misconfiguration within the ISE sphere. Cool. So it is important to have guardrails at each stages of your pipeline to spot those vulnerabilities as your attack surface is getting bigger. So we've seen, I've demonstrated with the application that I was using within the IDE, how to test and fix those vulnerabilities, and I can spot them when I'm coding the application, which is great. But this is also depending on your CI/CD pipeline that you've actually implemented within your organization. But you could test it at the repo level. When you raise the GitHub PR, then you can like test, fix, monitor, and also depends on your integration. If you're using other source for hosting, you can also test and fix within your CI/CD pipeline. So if you're using GitHub Actions, if you're using Jenkins or others, this is also a point a stage where you can implement guardrails. And on production, also, obviously, shifting left is important, but also having a look at what is going on the runtime with API security is also really important at the cloud level. And obviously, the registry, as I demonstrate with the Docker and the advisor, you can have also that visibility piece where you have vulnerable images. Cool. And having that DevSecOps feedback loop is really important, empowering developers to build applications securely within the entire development process. Because at the end of the day, we're all working on the same project. So we shouldn't work in silos. Developers and the security team should work hand in hand and have those like continuous feedback loop. And the developers should also have access to these tools to actually be empowered and have that ownership to secure the application. Cool. Let's see some defense in depth for all the level that we've seen in the iceberg. The first one, the open source components. So make sure to inventory your open source components, because you don't want to give hackers more tools to expand their exploits. So having that knowledge, that visibility is a good one. Leverage security tools, improve your security posture using software composition analysis tool, using static code analysis tools. Yeah, all of those like at every stage of your CI/CD pipeline. Embrace automation, because obviously you don't want to keep having manual activities. It's way better to have everything automated. And yeah, and also security policy. If you have a security action plan, make sure to include the OSS components that you have in use within your organization to have that visibility. And also using the SBOM, which identifies your software packages, the contents, and license data. It will give you that piece of information, which is important, critical. Containers. Don't run containers as roots. You probably don't need it. Don't use privileged containers as well. Drop capabilities. As I said, if during the development stage, if you want to have more capabilities, that's fine. You can use larger images. But when you push to production, make sure to actually have smaller secure images and drop the capabilities that you don't need. Make sure to also pull from known registries sources. And for the IAC level secrets, make sure that you encrypt your secrets and you're using role-based access control. Use also the security context. This is, as I've demonstrated, to make sure that you're not running as root and just to make sure of the access control. Start with zero trust and allow rules only as necessary, and make sure that you have all of these guardrails in place within your application. My top 3 tips. So I would recommend to adopt a DevSecOps approach or the shift left approach if you want to. This is to aim to detect security holes from day one in order to prevent security issues to begin with and to resolve them as quickly as possible if they do indeed arise. And also because it's cool to enable developers team and the security team to work all together and spot security issues at all stages of the software supply chain from design to implementation. My other top tips is to address open source vulnerabilities. I like open source ecosystem and working in that sphere, but we need to address if there's any vulnerabilities. We need to patch regularly. We need to have that visibility piece. So make sure to patch your open source components. And my third top tips would be security training for developers. Education is really important, because us developers were responsible for pushing the codes into production. So it's critical for us to better understand what is going on, to better understand the security terms, the jargon, the attack, the vulnerabilities, just to have this type of training. Obviously, the training should be tailored to the specific developer's role and security needs. Cool, so this is actually a nice segue to some useful resources that I'd like to recommend you. So the first one is the Snyk security resources. So we've actually worked on a few cheat sheets just to give you best practices. So you have around NPM security best practices. You have one on React security best practices. And you have also one covering the Docker Snyk log for shell. Obviously, there's more cheat sheets, but it's just covering for the JavaScript ecosystem and the Docker images. So have a look. There's really interesting cheat sheets that will probably cover your needs. And yeah, as I mentioned, the Snyk learn also entirely free, and you can keep progress, which is cool. You have your little session. So if you start, you can see like the progress, you can keep progress, and yeah, learn a little bit more about what is going on in the JavaScript ecosystem in terms of vulnerability. Really important. Cool, and lastly, the State of Open Source Security 2022. This is a report that the Linux Foundation Research Group and Snyk has collaborated on. And to give you an overview of the current state of the open source software security and some methods to improve your cybersecurity posture. This is really an interesting read if you're contributing to the open source, if you're curious about that ecosystem. Really great read. I would recommend it. Cool. So yeah, I'm Sunny Moisitz. I'm a senior security advocate at Snyk. I'm passionate about DevSecOps, open source, and cloud security. I'm not going to bore you with other stuff that I'm doing outside of Snyk, but if you want to reach out to me, you can ping me at Sunny Moisitz on LinkedIn. Yeah, just wanted to say thank you for attending. We fixed vulnerabilities.
Well done.
Yeah.
Well, that was fantastic, Sonia. And now I feel like strangers are not so dangerous to me anymore. I feel like I know how to defend against that. So there you go.
Thanks. That's because of Patch. So yeah.
Yes. Thanks to Patch.
Thanks to Patch. Yeah.
Yeah, and thanks to you, Sonia, for shedding awareness on all that stuff and how Patch can help us with that. I see a comment in chat from Nafron saying just thank you for the stream and sharing the resources. So there you go, Sonia.
Yay! Glad you enjoy it.
Yes, and I'm sure folks watching the recording of this will get a lot of value out of it as well. I think that's about it. We don't have too many questions going on in the chat room right now, but folks, if you do have questions later on, feel free to drop them in the comments below or reach out to us on Twitter, twitter.com/snyksec, right? That's the one. That's our Twitter account. I should know these things. I'm blanking. I think it's SNYKSEC. I'm guessing the just straight up Snyk URL was taken. We'll have to look into that. What happened there? In any case, we have more shows and content like this on our channels, twitch.tv/SnykLIVE and youtube.com/SnykSec. That's SEC at the end there. So you can catch more of this stuff. Be sure to follow, like, subscribe, whatever you feel comfortable doing on whatever platform you're watching this stuff on. We greatly appreciate it. And that way you can know of new content that comes out from us here at Snyk. With that, I think we can close things up. You have anything else to share, Sonia, before we go?
No, I think, just thanks, Patch. And I hope you enjoyed the today's session, that you've learned one thing or two on JavaScript vulnerabilities, and you know how to fix some of them, hopefully.
Absolutely. I had some takeaways there, especially from the demo that I had not seen done before in that demo application, that nodejs goof. So personally speaking, I thank you. I learned some new stuff from it. So yeah, it was definitely a success. And I feel other folks probably as well. So thank you, Sonia. Thank you, Patch. And thank you, everybody watching at home or wherever you are in the world. We appreciate you tuning in, and we'll see you next time. Have a good one. Bye.
Bye.